Tesla is no longer just a car company. If Elon Musk is right, it's about to become the world's biggest producer of humanoid workers. He wants to build 1 million Tesla Optimus robots every year, sell them for around $20,000 each, and use them to push Tesla toward a $25 trillion valuation. By the end of this video, you'll understand what Optimus really is, how it works, why mass production matters, and whether this $25 trillion robot dream is genius or pure sci-fi hype. Stick around for the real twist at the end, the one number that could make or break this entire plan. Humanoid robots have been science fiction for decades. But this time, it's not a movie studio building the robot, it's one of the world's most valuable tech companies. Optimus is Tesla's bet that the next trillion-dollar platform won't be a smartphone or a car, but a general-purpose robot that can walk into your factory, your store, or even your home and just start working. Production is already underway, at least in limited form, and Tesla says Optimus will soon be something everyday people can integrate into their lives, like buying a car or a smartwatch. If they pull this off, it doesn't just change Tesla. It changes what work looks like for the rest of this century. So what actually happened? In late 2025, Tesla-focused outlets reported that Optimus has entered mass production, with Elon Musk targeting a mind-bending goal, up to 1 million units per year once the factories are fully ramped. Musk and Tesla have been talking about this robot since 2021, when they first announced Optimus, also called Tesla Bot, at their AI Day event and showed early concept designs on stage. A prototype appeared in 2022, followed by a more capable Generation 2 robot in 2023, and then a Generation 3 showcase at Tesla's We Robot event in October 2024. Throughout 2024 and 2025, Tesla has quietly deployed Optimus for basic tasks inside its own factories, using it as a kind of in-house testbed for repetitive and boring jobs. At the same time, the company has turned Optimus into a marketing star, serving popcorn at the opening of a Tesla diner, and even appearing on the red carpet at the Tron Ares premiere in a playful kung fu face-off with Jared Leto. Behind the showmanship, Musk keeps repeating one core message. Optimus is not a side project. He believes humanoid robots could eventually make up around 80% of Tesla's value and push the company toward that $25 trillion dream. Optimus is built to be roughly human-sized, about 5'8", weighing around 57 kilograms, because the world is literally designed around human bodies. Doors, tools, stairs, factory lines. Instead of inventing a new shape, Tesla wants a robot that can walk into an existing warehouse or kitchen and fit right in, using the same aisles, shelves, and equipment that humans do today. Inside, Optimus is basically a walking Tesla car. Electric motors for joints, battery packs in the torso, cameras and sensors for vision, and an AI brain derived from the same software Tesla uses for its self-driving system. That means the robot is constantly taking in video from its cameras, building a 3D model of the world, and deciding, frame by frame, where to put each foot, how to move each hand, and how to keep its balance. Think of it like a self-driving car, but instead of steering and braking on a road, it's steering a body through a cluttered room while grabbing objects and avoiding people. The hands are one of the hardest parts. Even earlier generations already had many degrees of freedom so they could grasp tools, pick up objects, and perform relatively delicate motions like sorting items or handling small parts. Musk has described a future where Optimus can do almost anything you can think of: walking your dog, mowing the lawn, babysitting, serving drinks. But it's important to note that a lot of the flashy demos so far have relied on teleoperation, with humans remotely guiding the robot. In simple terms, today's Optimus is somewhere between an advanced industrial robot and a fully autonomous sci-fi butler. Impressive, improving fast, but still heavily constrained by physics, battery life, and software. Right now, Tesla's main use case is simple. Put Optimus into its own factories and let it take over the dull, repetitive, and sometimes unsafe tasks that humans don't really want to do. That can mean moving parts around, tending machines, handling inventory, or doing basic inspection tasks for long hours without getting tired or distracted. This is a smart move strategically. Tesla controls the environment, the workflows, and the safety rules, so it can tune the robot's tasks very precisely and collect tons of real-world data without having to sell a single unit outside. According to reporting on Tesla's internal roadmap, The company is aiming for several thousand Optimus units in 2025, scaling to maybe 50,000 to 100,000 units in 2026, and then up to 500,000 to 1 million robots per year by the end of the decade if everything goes right. Price is the other big piece of the puzzle. Musk has repeatedly suggested a target of around $20,000 per robot, with some analyses putting the likely range at $20,000 to $30,000 depending on configuration. If Tesla can actually ship a capable humanoid worker at that price, the pitch is obvious. Instead of paying a human salary year after year, you hire a robot once and let it work 16 or 20 hours a day with only charging breaks and maintenance. Analysts covering Tesla's new master plan describe Optimus as potentially the largest product opportunity in history, arguing that if labor becomes cheaper and more scalable than ever, entire industries, from logistics to retail to elder care, could be rebuilt around robotic staff. That's also where the $25 trillion number comes from. Musk and some commentators imagine a future where billions of robots are deployed globally, and Optimus ends up contributing the majority of Tesla's value, far beyond cars and batteries. Of course, this is Tesla and Elon Musk, so the gap between vision and reality is a major part of the story. Tesla has a long track record of overpromising on timelines, from self-driving robotaxis to solar roofs, and even Optimus itself has seen shifting dates and incremental demos that experts often describe as more hype than breakthrough. Independent roboticists have pointed out that many of Optimus's public demonstrations still rely on remote control or highly staged environments, making it hard to know how autonomous the system really is. Technical reports from 2025 mention issues like overheating, battery limits, and low payload capacity, which forced Tesla to pause and redesign parts of the system before moving toward newer Gen 3 prototypes. Beyond the engineering, there are social and ethical questions. If a humanoid robot can do dangerous, repetitive, and boring jobs at scale, what happens to the people doing those jobs today? There are also concerns about safety, surveillance, and misuse. Everything from robots being used for harsh labor control to more extreme scenarios like Musk floating ideas about robots monitoring prisoners, which critics see as a serious red flag. And then there's the simple financial risk. Tesla's core EV business is under pressure, with falling deliveries and rising competition, so betting heavily on a still unproven robot platform could stretch the company's resources if the ramp takes longer than expected. So where does this actually go? In the optimistic scenario, Tesla solves the hardest engineering problems, gets costs down, and starts shipping tens of thousands of reliable robots that prove themselves first in Tesla factories, then in warehouses, and eventually in homes and small businesses. In that world, Optimus becomes a kind of physical app store for labor. You buy a robot, download new skills over the air, cleaning, security patrols, basic caregiving, and your hardware investment keeps getting better with software. In the more conservative scenario, humanoid robots remain niche for years, expensive, finicky, and only truly useful in very controlled industrial settings, while other forms of automation, fixed robots, specialized machines, and software continue to dominate. Most likely, reality lands somewhere in between. Optimus becomes one of several serious humanoid platforms in a crowded market, and Tesla's advantage or weakness comes down to how fast its AI learns and how cheaply it can manufacture reliable hardware. Either way, the moment we start talking seriously about producing up to 1 million humanoid robots per year, we're no longer in the realm of a cool demo. We're talking about reshaping the global labor market, company valuations, and even the basic idea of what a worker is. Tesla's Optimus is more than a dancing robot on a red carpet or a popcorn-serving gimmick at a diner. It's a concrete bet that the next big industrial revolution will walk on two legs. On one side of the scale, you have Musk's vision of millions of $20,000 robots driving a $25 trillion company and ushering in what he calls sustainable abundance, where human labor is optional. On the other side, you have brutal engineering reality, skeptical experts, and a long list of ambitious timelines that have already slipped. So here's the question to leave you with. If humanoid robots do become as common as cars are today, what job in your life or your industry would you hand over to a machine first, and which one would you never give up? Let me know in the comments. That's it for this one. Thanks for watching. Don't forget to subscribe, and I'll see you in the next video.